A fuse is a small electrical safety device, but its job is very important. It is designed to protect an electrical circuit when more current flows through it than the circuit is supposed to handle. But how can a small piece of metal stop electricity and protect the rest of the circuit? To understand this, we need to look at what happens inside a fuse. Inside a fuse is a thin metal wire or strip called the fuse element. This element is placed directly in the path of the electrical current. When the circuit is working normally, electricity flows through the fuse element and continues through the circuit to power the connected device. The fuse does not normally interrupt this flow, so the equipment can operate as expected. The important thing is that the fuse element is designed to handle a specific amount of current. As long as the current stays within the safe range, the fuse element remains intact and electricity continues to flow. For example, if a circuit is designed to operate with a certain amount of current, the correct fuse allows that current to pass through without breaking the circuit. The problem begins when excessive current flows through the circuit. This can happen when there is a fault or another condition that causes the current to rise above the safe level. As the current increases, more heat is produced in the fuse element. The higher the excessive current becomes, the more the fuse element heats up. If the excessive current continues for long enough, the fuse element becomes extremely hot and eventually melts. When the metal element melts, it creates a gap inside the fuse. The electrical path is now broken, so current can no longer continue flowing through the circuit. This is the key action of the fuse. It does not detect the problem and repair it. Instead, it interrupts the flow of electricity by melting its own element. By breaking the circuit, the fuse stops the excessive current from continuing through the protected wiring and equipment. After the fuse element has melted, the fuse can no longer complete the electrical path. If you look at a blown fuse, you may find that the thin metal element inside has broken apart. The circuit is now open, and the connected equipment will no longer receive power through that path. A fuse that has operated this way normally needs to be replaced. The old fuse cannot simply be used again because its metal element has already melted. A new fuse with the correct rating must be installed after the cause of the excessive current has been checked. Fuses also come with different current ratings. This means that one fuse is not suitable for every electrical circuit. The fuse must have the correct rating for the circuit it is protecting. Using the wrong fuse can prevent the protection system from working as intended. So, the basic process is simple. Normal current flows through the fuse element. Excessive current causes the element to heat. The element becomes hot enough to melt. The electrical path is broken, and the flow of current stops. That is how a fuse works. It is a simple device that uses the heating effect of excessive electrical current to break a circuit and provide protection. From the outside, a fuse may look like a small and ordinary component, but inside, its thin metal element plays an important role in protecting electrical circuits. Normal current fuse element carries the current. Excessive current flows, heat increases, fuse element melts, circuit breaks, current stops.